Hi, hope you all are doing well. Today we will be talking about further session in measurement and instrumentation. Tell me what we measure when we travel. Do we measure displacement or do we measure distance? So let me tell you, our today's topic is displacement measurement, and we'll be talking about different methods of the displacement measurement with the instruments. This is under the semester 5 IC measurement in industries. I am a course instructor, Motion Pandya. And first of all, we'll see what is the difference between displacement and distance as we started with. So let us see here one figure. Here you see starting from point A to B to C to D, we have to travel in 3 minutes. Let us take an example of this skier. So the distance and displacement covered by the skier during these 3 minutes from A to B, B to C and C to D we have to measure. So A to B is 40 plus 100 plus 40, that is 180 meters. Then B to C, that is 140 further, and then C to D, that is again 100 meter. So this is what distance covered by this here is total 140 plus 100 plus 40, and then again 140, again 100, so that makes 420 meters in 3 minutes. Now, what is the displacement actually? So, difference between displacement and distance. Distance is actually we go through a particular path and we measure the in meters or centimeters or kilometers. And displacement is straight away from starting point to the end point. So, starting point here is A and end point is here B. So that is net is 40 plus 100, that is 140 meters. So here distance covered in 3 minutes is 420 meters, and displacement is straight away between A to D, that is 40 plus 100, that is 140. So by this we will be talking about displacement measurement. In normally people always miss to differentiate between distance and displacement. Okay. So displacement measurement can be done by various methods and sensors that I listed here. That is pneumatic transducers, optical transducers, electrical transducers, ultrasonic transducers, and magnetostrical transducers. Then we will be having digital displacements and proximity sensor. So today we will be talking about pneumatic transducers, and rest transducer will be coming in the upcoming sessions. And here we will be starting with the flapper nozzle assembly that we studied in the previous semester 4 under principle of measurement sciences. So pneumatic transducers here talk about the pressure. Pressure will be transferred in terms of displacement. So how does it work? Let us once again revise the concept of flapper nozzle, where we used to convert current to the pressure. Okay. So here you see the diagram where supply pressure is given at 20 psi standard supply, and it is passed from restriction that we say our orifice will be there, and then it will have two ways. The one will be going to the nozzle and another will be going to the signal pressure that you can read 3 to 15 psi standard. Now, supply pressure, then nozzle, then your flapper. Now, flapper is a movable plate which is pivoted at one point and balanced with the spring, and here a gap you can see between flapper plate and the nozzle of the pressure supply. Okay, and ampere we have supplied here is 4 to 20 milliampere. That will make an electromagnet over here. So what is going to happen now? As this magnet, let us go back a little bit. This magnet enters the iron piece placed on the flapper. The gap between flapper and your nozzle will reduce. So ultimately, whatever pressure we are supplying from the 20 psi supply line, the maximum pressure will go to the as a signal pressure. Now, if the gap is higher, like if we reduce the amount of current, okay, if we reduce the amount of current, the gap will be larger and more amount of pressure will be released from that gap, and here signal pressure will be reduced. So according to the gap, if gap is smaller, then the signal pressure will be higher. If gap is larger, signal pressure will be lower. So that gap is due to the electromagnetic activity, and that will represent the amount of current in terms of signal pressure. Now, what if we change the electromagnet with help of a physical moment? Here you see we have applied for 220 milliampere range, which is a practical range where we work in the industry, and continuous supply 20 psi we are making sure it will be reaching to the line. And in case electromagnets are activated. Now, what I am telling you is, if output this output pressure will be proportional to input current. So the question is, what if we use physical movement instead of electromagnetic action? So this electromagnet which is shown by the red arrow, that will be displaced by a physical movement of the object. Now let us see the little bit revised edition with this. So here what we are going to do is, we will be translating the displacement into pressure. Previously what we did current translated to the pressure, that is I to P converter. Now the diagram is little bit, 90-degree modified. Here you see flapper plate. You can see the X distance between the nozzle and the flapper. Now flapper is pivoted at one place, and one end is connected with the object. Okay. Rest of the things are same. PS is your standard supply line, fixed restriction, that is orifice, and whatever pressure is released at the flapper end, rest of the pressure, that output pressure, will be measured in the pressure chamber, measurement chamber we said. So let us have some terminologies, assuming the incompressible flow and equal discharge coefficient. I hope you all remember this from the previous semester study. And diameter, orifice diameter, nozzle diameter is given, fluid density, and pressure in measurement chamber, that is PO, output pressure, and known pressure supply, that was 20 psi standard in our case. Okay, and we understand that ambient temperature will be 0. Now gap between end of the main vessel and the flapper plate, that is X. Okay, that is written here. Now with these parameters we will go ahead. So once again the diagram is here. Now what happens? A fluid of known pressure is supplied through the restriction, and the X is the gap between flapper and the nozzle. So the body whose displacement is to be measured is connected with the flapper plate. So the motion of flapper plate will change the value of X. X between the flapper and the nozzle. So if X is smaller, this gap is smaller, so less amount of pressure will be liberating from that point, hence PO in the pressure measurement chamber, that will be higher. And if the X is larger, more amount of pressure will be released and there will be less value of smaller value of PO. So that will actually will be indicating the amount of X, and X is decided by the motion of the object, movement of the object. Now what we have to do, we will measure this pressure PO and you can calibrate in terms of displacement. So we had seen these equations, what I am going to see here once again in the previous semester, that flow through orifice, I again repeat, we assume incompressible flow with the coefficient C, and flow through nozzle, flow through orifice and flow through nozzle, these two equations we need to remember, where P ambient temperature is 0. So now what will happen if ambient temperature is 0, then both the flow will remain same. So we say Q1 is equal to Q2, and if you simplify the equation, you will get this ratio PO upon PS, which is in terms of, see, orifice diameter, nozzle diameter, and your displacement X. And again we recall the sensitivity of this transducer, that is in terms of the output pressure to the displacement. Here you say it is differentiation of output pressure and with respect to the your displacement between the flapper nozzle, that X we define. So if you simplify the equation, we need not to go in the depth, and we'll remember simply that Xi becomes 0.14 BO square upon Dm. That will be the maximum sensitivity point for this our transducer. Let us examine the characteristic. How does it work? So on the one axis we have x-axis we have displacement, that is X, and on the y-axis we have PO, output pressure, that is between 3 to 15 that we measure, and we supply it the 20 psi standard, that is indicated here, and the sensitivity will be the slope of this curve. So here you see the slope is almost linear between 3 to 15 psi, and practically because of that only we are using between this pressure and to measure, like displacement will be converted to pressure and pressure will be measured, and again that secondary measurement will be calibrated in terms of displacement. So when Xi is sufficiently large, that PO by PS becomes almost constant. So there is always a range, limited range, between which we can work to measure the displacement, and definitely this will be utilized for small amount of displacement to be measured. And you please remember this data, PO by PS is linear between 0.15 to 0.75, that is the range 3 to 15 psi pressure range. Otherwise, if beyond that large value of the Xi, PO by PS will become constant and will not be able to sense the displacement. Here I am showing you one small application, practical application, where supply line is created, where you see the nozzle with the red indicator, and the green is the release pressure from the orifice, and air supply, I get 20 psi. And again you see the displacement sensor is connected with the flapper, and flapper is connected with the piezo tube, and that will vibrate. So that vibrations will create the respective voltage signals, and ultimately we say the secondary measurement we are doing here. And the entire circuitry is created that will be converted to some analog signals, and then DAC is employed, and the entire closed loop system is created for the measurement of the a very small displacement in terms of X. So this was flapper nozzle assembly here, and the one of the important topic as per the GTU studies concerned from the chapter displacement measurement. And in next forthcoming session, we'll be talking about the optical transducers. We will be having variety of optical transducers, and we'll be talking about the how we use the fundamentals of light transmission to measure the displacement at the various methods. Thank you so much, and please solve the questions given in the description of this video and study well. Thank you.